All right. So yesterday we talked about some different formulas, also called the addition subtract formulas or the addition subtract identities. These are ways to modify a trigonometric function specifically for uses in solving with unit circle. Values that are not currently on the unit circle will be found by modifying unit circle values using the formulas on the board and on your cheat sheet. So let's get started. Tangent of 75. The first part of these types of problems is figuring out how they go together. So I have to figure out how the tangent of 75 fit together. In other words, what are two numbers on the unit circle that add to 75? 45 and 30 is a great starting place. So let's recognize that fact. Tangent.
Tangent of 75 degrees would be equal.
Okay. Now from here, once I've recognized my two values, we refer to in this section as alpha and beta. Those two values are then going to go into this trigonometric function. Now, for tangent, as I discussed yesterday, our goal for next week is once again no unit circle. Tangent, remember, is that third ring and is not on the unit circle anyway, so that's even more fun. For today, I will let you use a calculator, but starting next week, get them down again. Let's do it. Tangent of 45 plus 30 is equal to. So I'm going to use my tangent formula and use my sum formula.
Are these on our things? Yes.
Yeah, they are. Go to the addition section.
Right here. Where? Right here. I said, shut up.
Alright, let's go. So we have tangent of alpha, so tangent of 45, plus tangent of beta, so tangent of 30.
Oh, we didn't do these.
Now the tangent ones. So, divided by 1 minus tangent of 45 times tangent of 30. I'm on London focus. Alright.
Minus.
So, as weird as it sounds, the tangent ones are harder, but in some ways they're also a little nicer. There's only two numbers I need to know. Tangent of one of the numbers and tangent of the other numbers. Whereas in the other trig functions, I have to know 4 values. So even though these are harder values, there are fewer of them. Now, what I would recommend is use it for the smaller pieces, because that's the part you'll be using for the unit circle.
Actually, I got
do it.
Circle right here.
Equals. On top, I need to figure out what is tangent of 45 plus tangent of 30. Then on bottom, I need to find 1 minus tangent of 45 times tangent of 30. And then, when possible, we're going to simplify. So, let's fix this. Tangent of 45
is 1.
1 plus
Square root of 3 over 3.
square root of 3 over 3.
1 minus 1 plus or times square root of 3 over 3.
So, one version of this answer, the unsimplified version, looks like this.
Does it have to be simplified? Did you say it did?
Yep.
Fudge. Oh, I'm sorry about you. 1 plus.
So, that is the unsimplified answer. Now,
what?
To find the simplified version of this answer, I'm going to need to use two properties from algebra. Let's go ahead and get started. First, just like with last week, the reason why we talked about last week first is I'm going to combine the top two things together by combining fractions, and the bottom two things together by combining fractions, which is one of the steps we did last week. I'm sorry, this week. This is like a long week, huh? And then after that, we're going to use keep up change, the reciprocal rule, to multiply them to the top. So here we go. So on top, this first piece becomes not 1, but 3 over 3. That one also becomes 3 over 3. Remember, I need to have like denominators to get this to work. So now I combine my fractions. The top becomes 3 plus the square root of 3 over 3, divided by 3 minus the square root of 3 over 3. Now I use the KFC method, or multiplying by the reciprocal, to get this from two big fractions to one smaller fraction. The top stays the same, 3 plus the square root of 3 over 3, times, the bottom gets flipped. This becomes 3 over 3 minus the square root of 3.
No. I think.
So, 3's cancel, and we're left with 3 plus the square root of 3 over 3 minus the square root of 3.
Oh, it's duh.
It's alright, man. It's alright. Take your time. Don't let cold negativity ruin a good day. Now, in some circles, this is still considered unsimplified. I think in the book it's also unsimplified from here. We have to continue further. There's one last thing you got to use.
What?
That's why the tangent one's the most fun. That's also why when you look at your homework for the weekends, you'll notice there is one tangent problem compared to like 8 of the others. Okay? It's because you're supposed to have this one be the fun struggle. Those two words rarely go together. So, here we go. Next one. In order to get this thing simplified. So, before I continue, started here, separated into 45 and 30, wrote into the formula, simplified the formula using unit circle, and now the rest from here on is algebra, algebra, algebra. Speaking of which, I am now here. How do I fix this? How do I get this thing simplified?
What? That's not simple.
Yeah, no kidding.
Oh, God.
Well, you have to get the radical out now.
Correct. From algebra, if you had been Stancy, you might have heard the phrase jumping right around with the radical down. Some other math teachers use it too. I'm not a huge fan of it because, well, it just sounds dirty. I cannot have that radical in the denominator. So, if I want to get the same answer the calculator has, I have to multiply by what's called the reciprocal, or in this case, the conjugate. So, I take this function, multiply it by. Now, in algebra, there is a very specific fraction called the conjugate, whose sole purpose is to get rid of this radical in the denominator. Let's see if that's big algebra brains today. Conjugate. What is the conjugate to this function? Madeline?
3 minus 3.
Incorrect, but very close. It is the plus. Now you might be looking at this and going, but that's the top. Do I always multiply by the top? No. What you want to do, so this piece is called the conjugate. If you need to, look up this term. It is an algebraic term. It is a common algebraic term. The conjugate always applies to the denominator only. It comes from here. The bottom number always defines the conjugate. The top is irrelevant. The top could be literally anything. It could be a 4. And the conjugate is defined by the denominator every single time. The conjugate is defined as, if I have two numbers, a plus b, so one of these could be radicals, it could be anything you want. The conjugate is the reverse of these, a minus b. And it works both ways. So if I have subtraction, the conjugate is just the addition version. If I have the addition, the conjugate is the subtraction version. But it always applies to the denominator. So you want to conjugate the denominator. Always, 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 always. Whew. So, last thing, from algebra, I FOIL and I fix this. My final solution, as the calculator would tell me. Here we go. So, on the top, I would take 3 plus the square root of 3 times 3 plus the square root of 3. On bottom, I would take 3 plus the square root of 3 times 3 minus.
It take way too long.
That's why there's only one in your homework.
Huh?
Why there's only one in your homework. Okay. Let's simplify. On top, I FOIL. 3 times 3, 3 times square root of 3, square root of 3 times 3, square root of 3 times square root of 3, one piece at a time. Let's do it. On the top, the big fraction. 3 times 3, that's 9. 3 times the square root of 3 is 3 times the square root of 3. Square root of 3 times 3 is 3 square root of 3. And square root of 3 times square root of 3 is just 3. Square root and square root cancel.
Yeah, I'm just gonna leave it alone. If we leave it, hold on, I got a question.
Oh, I love this question. I know what that question is already going to be.
And he's going to tell us we have to simplify.
What's your question?
Okay, never mind.
No. Cole, ask the question.
If we leave it like the underlying one on the test, right or wrong?
You mean this one?
Yeah.
Oh, if it's so usually these are 5-point problems. You're getting like 4 points.
Oh, okay. I'm missing one.
I'll take one from away.
And I'm working through it, so I want to make sure I get the answer, because otherwise, it's hard to believe that this gets the same answer the calculator does. So at least you should see it once. So let's keep going. On the bottom, I multiply again. I FOIL through. So when I FOIL, 3 times 3,
9.
3 times negative square root of 3, square root of 3 times 3, square root of 3 times negative square root of 3. Let's do it. On bottom, I get 3 times 3 is 9. Yes. 3 times negative square root of 3 would be negative 3 square root of 3. 3 times square root of 3 would be positive square root of 3, 3.
I don't think I've ever wrote so many numbers on a
Let me guess, that's not simplified.
Well, one last thing to do.
Can cancel.
Combine like terms and cancel stuff. All right.
Threes cancel out. One of the positives, one of the negatives cancel out.
Yep, those cancel. And on bottom, I'm left with 9 minus 3, which is, of course, 6. On top,
Nothing cancels out.
nothing cancels out, but we can
But
combine them
combine,
together.
yeah. So
9
12.
and 3 makes 12.
But so that'd be 1 half.
And then
I mean, that'd be
3 becomes 6 square root of 3. All right.
But then the 12 and 6.
The 12 and 6, the 6 goes into both of those. How many times will
2.
6 go into 12? 2. And the 6 and the 6 cancel, but there's still a square root of 3. Go to your calculator, please. Type in tangent of 75. Do we get 2 plus the square root of 3? I hope so.
No.
If not, I made a mistake.
We done yet?
We're done.
Are we there?
Are we there yet? We're there yet? Alright, we get it?
I took up a third of my page.
Oh. I love that sound.
Are you paying for my paper bill?
I got paper to spare. You can borrow some of mine. I will pay that big bill. Although I might charge a tax for that reason. Okay. As you can see, as you might imagine, the tangent ones are the most fun. Fun being a very loose and misinterpreted word here. Mainly because there's a lot to simplify. Okay? Well, the other ones are much easier. Not only does the tangent one have the complication of not being on the unit circle, but it also has the double complication of having these pieces that have to simplify nicely. And some of them do not simplify any nicer than this. This is actually pretty average for a tangent function. You have one of these in your homework. I suggest you take your time and try it out. Use it as a great example. I will post a video this afternoon, so I don't forget. Thank you, London. So, you remind me after I post videos. So thank you.
Oh, I was like, what?
Always remind me if I forget something. All right.
Yeah, I was waiting and I was like, I think you
Let's
forgot.
go back and do one more easy one. Let's abandon this tangent function for a while.
Sounds good to me.
But again, when you have your tangent function in your homework tonight, I would strongly suggest come back to this part of the video, look at this problem, watch us walk it through. It won't be exactly the same, but it will be pretty close. Okay, here we go.
Is our homework due Monday?
No. So what I'm going to do, I'm going to give the entire homework assignment, but tell you to do only specific parts at a time. So I'll be like, hey, for the weekend, I want you to do these 8 problems, but the entire homework will be due next week. And then on Monday, I'll be like, hey, now do these next problems, so you know which sections go with which part of the homework. Here we go. Let's do a nice simpler one. A little nicer. A little simpler. How about sine? I got sine of 165 degrees. I don't think I did that one yesterday. Fun one?
Sine of 165.
Sine of 165. The first thing I got to do is find 2 numbers that come together to make 165. Now, again, ones that are not in the unit circle are not helpful. So if you're like, hey, 20 and 145 go together, it's like, yeah, cool, but 20 is not in the unit circle and 145 is not in the unit circle. Find some that are. This problem, what do you recommend?
120 and 45.
120 and 45? Love it. Anybody see one different, just on the off chance? There's a couple of them. 135 and 30 would work. Let's see. The only other one that I thought of was 210 minus 45. But there are more. You know, they're just kind of where you want to sit. Like I said, I try to pick the numbers where I have the most things in the first quadrant, because those tend to be the easiest. Let's do it. All right. So I recognize that these are the two components. This will be my alpha. This will be my beta. So let's plug those two things into my formula. Sine of 165 is equal to, I go to the sine function, I use the 165 formula. Sine of alpha, so sine of 120, times cosine of beta, so cosine of 45 degrees, plus cosine of alpha, so cosine of 120 degrees, times sine of beta, so sine of 45. Some really smart Greek people. Alright. If there's actually in the book, I'd never seen a book do this before. They actually laid out the original proof for how these formulas came about. If you're interested in knowing where they come from, look in section 9.2 near the beginning of the chapter. They show where a lot of these formulas come from. It's really neat. It's very visual. I like it. But if you're not interested in that, then the formulas are just here in the work. Here we go. Equals. So I now need to find four things in the unit circle. Sine of 120, cosine of 45, cosine of 120, sine of 45. Let's go to the unit circle. Sine of 120. So again, reminder, sine is the y value. We're looking for the y value for 120. That is the sine of 120.
Square root of 4.
Huh? Square root of 3.
I know where you're going, but. Alright, cosine of 45?
Square root of 2.
Square root of 2 over 2. Plus.
Negative 1 half.
Negative 1/2.
Square root of 2 over 2.
Square root of 2 over 2.
Did you see that?
So what's important here is this is a negative being applied to the 1/2. So what's going to do is it's going to turn this plus in between them into a minus in between them. Alright, let's simplify algebraically. Equals. So square root of 3 times square root of 2 would be square root of 6 over 4 minus square root of 2 over 4. And then they have the same denominator, we just subtract the tops. Again, algebra comes in quick here. The top is square root of 6 minus square root of 2 over 4. And reminder, you cannot add or subtract radicals unless they have the same base structure. Square root of 6 is not equivalent to square root of 2 in any way, so those two just stay separate, and this is your solution. Remember, you cannot combine the other radicals.
For all of those of you who have been patiently waiting,
Check.
third place was
Check this. Make sure I'm right.
Second place, Bradley Taylor. And the winner of the Ultimate Mullet, Ashton Wiggs. Congratulations to all of our worthy contestants.
No.
You know what I never see? You're over the model.
I think there was a girl in the competition.
There was?
I think there was. I was looking at a video there was something.
Just trim the top into a pixie cut and just leave the back flowing?
No shot.
I think that'd be pretty funny.
London, you should do the mullet.
Okay.
All the baseball boys like having the mullet. Just be like, Mom, just
I'm just fitting it.
I don't. I cut all my hair off.
thank you. It's terrible.
I appreciate it.
Alright. Should we check with the calculator to match up? Luis is shaking his head yes. Sorry. Oh, everybody else right this.
She want you to get her.
There we go. Alright. So,
Yeah, before problem.
in general, as you can imagine, sine to cosine is pretty easy as long as it's in a circle. The tangent's annoying because there's a lot of algebra in them, but again, it's just plugging into a formula and then simplifying. Where these have some quirks is the final part for today. We've been doing everything in degrees.
No shot. I'm not.
Let's do it in
Douglas, no.
Radians? Or radians?
What is
Oh my.
cosine of pi over 12?
It's-
This is where we
Douglas, what the fuck?
split the wheat from the chaff. Once again, I have to figure out two values that simplify to my value by addition or subtraction. Now, a word of advice. If you're not good with the radians, there is a way to convert.
Yeah, you can convert them to, but then you gotta convert them back to radians, don't you?
Why?
Oh, bet.
So
Now.
I have to.
Okay.
For those that want to go on to calculus, I will tell you, and this is a select group, so that's why I'm not telling everybody to do it this way. If you're planning on just this being like one of your last math classes, so I get it, that's fine. I don't judge. What you're going to tell you to do is if you're struggling with this particular part of it, convert these into degrees and continue. It's not too bad. If you wish to go on to calculus, if you're in that student that's like, hey, I signed up for next year, then get used to radians. Everything in calculus is in radians. You don't touch degrees the entire year. So just get used to it. You have to know it. So, up here, I'm going to pretend that all of you are doing this. We've acted the entire problem in radians. Yay! I don't want that. Alright, so I need two values that simplify to pi over 12. Now, fraction math is one of those things that people who have it usually have a pretty easy time with, who don't tend to struggle a lot with it. So, this one, my two values are going to be cosine of, and if you've already converted it to degrees, you probably already know what the two numbers are. In this case, it would be pi over 4 minus pi over 6. Now, if you convert this into degrees, this is asking for cosine of 15 degrees. 15 degrees we can find by doing 45 minus 30. 45 is pi over 4, 30 is pi over 6. Thus, I have my two values. Like I said, the people who wish to go on and get used to dealing with radians, people who don't, I'm not going to sit here and punish you and demand you do it this way, because guess what? When you do your test, I never see the answer part of it. I never see which one you use, because you usually just jump straight to the values you plugged in. So who cares using radians degrees after that? Okay, so got my two values. I'm pretending I'm doing everything in terms of radians, so we got this. I do cosine, I'm doing a subtraction problem, so I'm doing the difference formula. I go to cosine, I'm using this fourth formula on the board here. It says cosine of alpha times cosine of beta, so again, my alpha, my beta.
Do we have to put negative?
Here we go. Cosine of alpha, so cosine of pi over 4, times cosine of pi over 6, plus, because remember, the sum difference formula for cosine, the difference formula has a plus in it, sine of alpha, pi over 4, times sine of beta, pi over 6. Okay, I'm running my unit circle. You're my best friend. Alright, cosine of pi over 4, cosine of pi over 6, sine of pi over 4, sine of pi over 6. Let's plug them in and see what happens. Cosine of pi over 4, that is square root 2 over 2. Cosine of pi over 6. Cosine of pi over 6, wait, that's square root 3 over 2. Plus sine of pi over 4, that is square root 2 over 2. Times sine of pi over 6, that is 1/2. You notice that a lot of these have similar structure. That's why it's important that you get the formulas right. Because the structure, yeah, some of them, a lot of them have pi over 6 in them. Or sorry, square root of 6 in them. A lot of them have square root of 2 over them. But you have to get the structure right though, because if it's plus or minus, matters a lot. They're coming here. Put everything in. Is equal to. Again, I multiply top times top, so that gives me square root of 6. Bottom times bottom, that gives me 4. Plus square root of 2 times 1 is square root of 2. 2 times 2 is 4. Looking pretty good. Add those two together. Remember, we add the tops, but keep the bottoms the same. And this should be my solution. Calculator and verify. Make sure it's in radians. It needs to be in radians to check this answer. Cosine of pi over 12. All right. The tricky part about the radian one is if you need to stay in radians, you've got to be able to do the fractional math. If you don't need to stay in radians, well, you can kind of work around it. We've got 10 minutes left. Let's do a couple more examples with the radian version. Again, if you struggle with the radian part of it, convert it into something else. You know, the other one we talked about a lot. If you don't remember the conversion formula, everyone you might want to look up. It's in our notes. Okay? We have it. Alright, next one. I'm going to do sine. Ow. sine of 5 pi over 12. Now, I will show, for those of you that are wanting to move on, how I can do some of these without really needing extra help, like conversions. Like, I find a nice little trick you can do with this. So in this case, again, if you are doing it by converting it into degrees, don't watch what I'm about to do. If you're going to do it with the radian version, take a look, see if you like what I'm going to show you. And if you do, use it. If you don't, don't. Sine of. So, 5 pi over 12. As a reminder, what this is, it's eventually going to split into two fractions. Those two fractions, I choose what they're going to be. So let's look at some pieces that could come to 5 pi over 12. Well, what about 1 pi over 12 and 4 pi over 12? Right? Those two add to 5 pi over 12. Now, 1 pi over 12 is not on the unit circle. 1 pi over 12 is on there. 4 pi over 12 reduces down to pi over 3. That is on there. So one of these works, one of these doesn't. This means that this one is not a good fit for this problem. So I'm going to go ahead and eliminate 1 plus 4 as an option. It didn't work.
Oh, so you're talking about the top.
Yeah. Because remember, when you add fractions, the bottom stays the same. So when you take them apart, the bottom will stay the same as well. Remember, I want this to reduce to two things that are in the unit circle.
So now it's going to be 2 and 3.
Well, let's look at 2 and 3. If I use 2 and 3, what do I get? Well, so 2 divided by 12 would be pi over 6. Oh, that's a 3, right? Yeah. That should be a 3. Thanks, Douglas. And then 3 pi over 12, that should be pi over 4. This is one trick I like to use. Because again, it works the same basic way as you did it with algebra, but yeah, it works very nicely. But you end up having to reduce a bunch, and if you choose the wrong couples, like, these numbers can be less nice. You have a homework problem tonight that asks you about this. It says something like sine of 19 pi over 12. And so your options are like 1 pi over 12 and 18 pi over 12. 2 and 17. 3 and 16. And some of those might work and some of those might not work. So you gotta kind of just flow with it and figure out what you think works best. Again, this is just my trick. I've used it for years. I like it. Some of you may not. I know this is primarily on addition, but there's a similar process you can use for subtraction. Because again, you can ask what numbers could I subtract to get 5? Well, what about 7 and 2? If I subtract 7 minus 2, I would get 5. What are those on my unit circle? That becomes the next big question. Okay, so I have now successfully found my two pieces. Sine of pi over 6 plus pi over 4. How I come up with those two pieces, whether I convert it into radians or I continue from that form, is up to me. But now I continue the problem. Sine of pi over 6 plus pi over 4 is equal to, again, my alpha is going to be my pi over 6 for this problem. My beta, pi over 4. Let's plug them in. I'm doing sine, I'm doing addition, so I go to the top formula. It says sine of alpha, so sine of pi over 6, times cosine of beta, so cosine of pi over 4, minus, plus. That's why you have the formulas. So plus cosine of pi over 6 times sine of pi over 4. All right. Let's do it.
1 over 2.
1 over 2? Yeah. Times
Square root of 2.
Square root of 2. Plus
Square root of 2.
square root of 2.
Square root of 2.
Square root of 2.
And you get
Hey, look.
square root of 2 of 4.
It's the exact same solution. Remember, many of these trig functions have duplicate solutions because they go around cyclic. But if I type in sine of pi of 5 pi over 12, I should get that same solution because it is the same solution. Just the cosine uses a different number to plug in and get it. So, these are the reading notes. Now, as a reminder, I will be posting the homework here in a minute or two. The entire homework is more for the whole section. We will skip around the problems because the problems don't go in order that I like. Example for tonight's homework. The weekend, you'll be doing 4 through 9. Yes, that was 4 through 9. And 42 through 46. Like, it's kind of random. If I'm going to give you the entire homework assignment because you want to work ahead, you might want to figure out some of the other ones on your own if you want to. But we'll talk about the rest of the sections on Monday and Tuesday. Okay, any questions using these formulas, either degrees or radians? Okay, then I will post the homework here shortly.